Okay, in lesson 1.6, we're looking at solving other types of equations. So first thing here we have is a higher order equation, so it's not a quadratic, it's even got a higher power on x. We would work on this problem with factoring. So the first thing we need to do is get everything on one side and set it equal to 0, because factoring, when you factor and those factors multiplied together give you 0, you know that one of those factors has to be 0, and that's how you solve it. You might be tempted to divide both sides by x squared so that you could cancel out x squared, but you can't do that because x is unknown and it's possible that it could be 0, so you never know. 0 actually is a solution of this equation, so dividing both sides by x squared is not acceptable. You can never divide both sides of an equation by a value that you don't know, because it could be 0 and you can't divide by 0. Alright, so what you're going to do here is you are going to just move everything over to one side. So subtract 48x squared on both sides, and now it all equals 0, and now you can factor out the common factor, which is 3x squared. So if you factor out 3x squared, you're going to be left with x squared minus 3 goes into 48 16 times, and that's going to be 0. And so now you've got 3x squared times x squared minus 16. X squared minus 16 is a difference of squares, so that means that if you factor it into its conjugates, x squared minus 16 is x squared minus 4 squared, so the conjugates are x plus 4, x minus 4. So now you've got three factors here that multiply together give you 0, which means that one of them has to actually be 0. So 3x squared could be 0, x plus 4 could be 0, x minus 4 could be 0, and it would make that 0. So x squared, 3x squared equals 0 means that x squared itself must be 0, so x would be 0. So that's one solution. It's a double solution actually, because x times x, that's actually two factors that both would equal 0. X plus 4 equals 0. If you subtract 4 on both sides, you get x equals negative 4, so that's one solution. And then x minus 4 equals 0. If you add 4 on both sides, you get x equals 4. So those are the three solutions. Actually, this one counts twice, so 4 solutions to this equation. You always get the number of solutions is always going to be the same as the highest power on x. All right. This problem here is a cubic, and it's not obvious right away how it would be factorable, but in that case you want to try to factor by grouping. So you could group it into two groups and factor the first group, which has a common factor of x squared in it. So if you factor out the x squared in the first two terms, you're going to have x minus 3 left over. And then the second two terms have a common factor of 3. So if you factor out the 3, you have x minus 3 left over also. So now you have two factors with a factor of x minus 3 in each one. You can factor out the x minus 3, and you're left with x squared plus 3. So we were able to factor it at least a little bit. So now we have two factors that multiply together give you 0, which means that one of them has to be 0. So either x minus 3 is 0 or x squared plus 3 is 0. So if x minus 3 is 0, add 3 on both sides, x is 3, so that's one solution. And over here, you subtract 3 on both sides, and then you take the square root on both sides, x equals plus or minus the square root of negative 3, and you would write that as plus or minus the square root of 3i. So these are the three solutions, 3, positive square root of 3i, and negative square root of 3i, that would solve this equation, which is a third order equation, so it has 3 solutions. Here we've got another equation that has factorableness to it. It can be factored. It looks a lot like a quadratic, except that this is a 4 and this is a 2. Instead of usually it's a 2 here and a 1 here for those exponents. So you can factor it out using the kind of unfoiling method where you write two binomials. So you look for the first two things that go here and here should multiply together, give you x to the fourth. So x squared and x squared. And then the last two numbers should multiply together, give you 2. So 2 times 1. And then if you make both of those minus, you're going to get minus x squared minus 2x squared, which is going to give you minus 3x squared in the middle, and that's what you want. So that would be how you can factor that. So now you have two factors multiplied together, give you 0, and you know that one of them has to be 0. So either x squared minus 2 is 0, or x squared minus 1 is 0. Add 2 on both sides here. X squared equals 2. Take the square root on both sides. X equals plus or minus the square root of 2. Over here, add 1 on both sides. X squared equals 1. So x equals plus or minus the square root of 1. So x equals plus or minus 1. So these are the 4 solutions to this equation that has the highest power on x being 4. It has plus square root of 2, minus square root of 2, plus 1, and minus 1 for solutions. All right, solving radical equations. Whenever you have an equation with a radical in it, at some point you're going to have to square both sides to make that radical go away. Whenever you square both sides of an equation, you have the potential to add solutions that don't really work in the original equation. For example, if I have the equation x equals 2, that's a very simple linear equation with one solution. The only solution to that equation is 2. 2 is the only thing you could plug in for x that would make this a true statement. It would be 2 equals 2. If you square both sides of that equation, it becomes x squared equals 4. X squared equals 4 is not so simple anymore. Now it's a quadratic equation that has 2 solutions, plus or minus 2, because 2 squared is 4 and negative 2 squared is 4. So this equation has an extra solution that this equation doesn't have. So when you square both sides of any equation, you might add solutions that don't actually work in the original equation, and you always have to check your final answer to make sure that it actually does work. All right, so if we were going to solve this equation, the first thing we would do is isolate the radical. Get the radical all by itself, move everything to the other side. So you've got 2 square root of 2x plus 7, add x on both sides, and you would have x plus 2 over here. Now I'm going to square both sides of this equation. Whenever you square a square root, the square root goes away, and you end up with just 2x plus 7 on the left side. On the right side, if you multiply x plus 2 times x plus 2, which is what you have to do here, it's not equal to x squared plus 4. That's not how this works. X plus 2 quantity squared means multiply x plus 2 times x plus 2. FOIL it out, add the like terms. You're going to get x squared plus 4x plus 4. All right, now you're going to isolate. Well, you're going to have to, this is a quadratic, so you're going to have to get everything on one side and then solve it. All right, so if you subtract 2x and you subtract 7, then move everything to the right side, you're going to get 0 equals x squared. You got 4x minus 2x minus 7 over here, so plus 2x minus 3. All right, this is factorable because 3 times 1 is 3, and positive 3x minus x will give you 2x. So this equation can be factored. Therefore, x plus 3 is 0, or x minus 1 is 0. If you multiply two things together, that gives you 0. That means that one of them has to be 0. So x equals negative 3, or x equals 1. So I've got two solutions here. I need to check both of them in the original equation to make sure they work. So I'll try 1. Check x equals 1. So I'm going to put that into that equation. I'll have the square root of 2 times 1, which is 2, plus 7, minus x, which is 1, equals 2. So that is the square root of 9 minus 1 equals 2. 3 minus 1 equals 2. That's true. So x plus 1 is a solution. All right, now I'm going to check x equals negative 3. So I'm going to do that over here. I'm going to put it into the original equation. So I've got 2 times negative 3 plus 7 inside the square root minus x, which is negative 3, equals 2. So that is the square root of negative 6 plus 7, which is 1. And then it's minus negative 3, so plus 3 equals 2. 1 plus 3 equals 2. No, it does not. So this, x equals negative 3, is not really a solution of the original problem. So the only solution you would write down would be x equals 1. So, as I said, all the solutions may not work in any situation where you square both sides of the equation. That's when you're adding solutions that may not really belong. All right.